Okay, so hash tables. So we have essentially, we're going to be using some caches to do this tonight. We're going to be working with our cache. A cache is kind of like a hash table, which kind of like a dictionary. It basically is, but it's different. But they're functionally similar enough for our brains to think about things. So what this is asking us to do, we have a math problem here, and it wants us to run this on every number. All right, can you make your IDE take up the whole screen for us, please?
All right, sure. I was trying to take notes, but yeah, maybe this time I should just listen.
Yep. So you're gonna be the typist this time. So it's gonna
All
be
right,
your job to type everything.
All right, I'm gonna type copious notes.
All right. So what they want us to do is find a way to write this so that we get an output, but it's going to be quickly instead of forever.
Right.
So if you tried to run this right now, it would take so long. But with the
do you know that factorial
of
has that time what is it, run time? Is that why?
Yeah, it's going to run really slowly. So what we're going to do in slow fun at line 17 is we're going to start. So here's our new, so here's our, this is going to be our solution here. We are going to start and make it run quicker. So actually outside of slow fun, so before at line 14, we're going to instantiate our cache. So right here at line 11, this is outside of the definition of slow fun, outside of the function.
Okay.
Yep. Give it some space, a little bit more space. There you go. On line 12,
right.
Cache, CACHE, equals, and just give me an empty dictionary.
Oh, dictionary?
Empty dictionary. Remember, we're working with caches, dictionaries, hash tables tonight. So
is like a dictionary.
Yeah. So now on line 21,
okay,
we're gonna do something pretty straightforward. If
what is that
parentheses?
Noise? You guys hear that? It sounds like somebody like
playing cards.
Yeah, thumbing through a list, a group of cards or something.
You know, it could be my mic, but I don't know.
Unless it sounds like someone slurping a soda.
You want me to get my headphones and see if it's any better?
It's fine. That's just gonna run the clock. Okay. All right. So tab inside your if statement. There you go. So if parentheses.
Yeah.
X, Y, X, comma, Y.
That's going to make this video really hard to listen to for other people.
Oh, I can mute myself then, or just...
Okay, that'll work. Yeah. That'll work. Make sure you keep your lookup table as the full screen.
Yeah, let me, oh, I have to escape. Here we go.
Okay. It's going to be a weird class talking to myself. Okay.
No, I mean, I'll unmute it to talk to you, but unless...
All right, so if XY not in cache. Put some nice spaces in there. Make it Pythonic, please. Space if space XY not in cache. Colon, because we're going to make that the end of the line. Now, I know we're not supposed to do this. Copy. Copy lines 5 through 9. Yep. And paste that here. So we're going to do the function on that. Yep. The whole thing. Right there. Tab the V back, please. I think, wait, no, which direction? Sorry, in. Tab them in. All right.
Is there a way to untab?
Yes, but you don't need to. They're exactly where they need to be.
Oh, yeah, I agree.
So if X and Y are not in the cache, so right now our cache is going to, our dictionary, right, is going to look like X and Y as our key, and then we're going to have our value, okay? So if X and Y are not in the cache, we'll do some math, and then on line 26, we're going to add them to the cache. How do we add something to our cache?
You append.
Appending is for lists. So we're going to write cache. So we say the name of our dictionary, which is cache. And then we're going to access the key. The key. Where's the key of our cache? The key of our cache is,
it's X, but maybe I'm wrong.
it is going to be X and Y, just like I wrote up here. X and Y with a pair. So put a little, there you go. It's little X and Y, and that equals, and our answer is, in this case, V. Yep. And then, well, that's it. That's absolutely 100% it. So what we have done is we have created a cache, which is our dictionary. We've said, hey, for X and Y, if X and Y are not in our dictionary, are not in the cache, do all this stuff, and then add X and Y as our key with our value as our value for whatever this is. And then it's going to be part of our dictionary. So for example, again, Ava's not very creative at math. We have our value of 1 and 1. Then we would have that be, come on, 2, for example. And then we have another pair of 1 and 2, where our answer would be 3, and so on. But if we have 1 and 1 again, do I need to do the math if it's in the cache? I do not. That's what makes it run faster. Give me a thumbs up if that makes sense. Awesome.
I just want to know the X and the Y is just the key and the value, correct?
The X and the Y are our parameters. They're right here. They've been passed in as our parameters.
What exactly are they? Just, we don't know.
We don't know. They could be any value at all. That's what it's like algebra. We have X and Y. So they could be literally any value. And that's it. That is this very first lookup table. Ta-da! So we have a dictionary. We're checking if our parameters are going to be in our dictionary. If yes, then no. If they are, skip. If they're not, do some math. All right, see you, Joanne. And then we're going to return a dictionary value. We're going to return a new key value pair as part of our dictionary. All right.
Do we need a statement for that?
Nope. That's it. Return cache, sorry. And then we return our cache at the very end. And that is it. Ta-da!
Indent, is that like that or one?
Yeah. Outside at the definition.
Oh, outside.
If you put that on the inside, it would stop it after the first time.
Okay.
So there we go. Okay. Now when you are done making your notes, we're going to move on to the expensive sequence.
All right. You said it would have stopped the looping?
If you put, because remembering that Python pays attention to space. So you want to keep your scope even. Right?
All right, so you want a different the other file now?
Yep. Now we're going to go to another function, which is called expensive sequence. Yep. Go ahead and open it up, drop it down, open it up. Expensive sequence right there. There we go. All right. So if you take a look at this little for loop right here, it's got some math that it wants us to do. Cool. So we are going to write an expensive sequence that allows us to loop through all of the numbers that it's going to give us. This is a whole lot of numbers. And return our cash, essentially. All right. So the first thing we have to do is outside and before our function. We're going to instantiate our, what are we instantiating?
Cache.
Yes, go ahead and do that.
Oops. Okay, so the cache. What was it? It's like 0. We need like this.
The what? It's an empty dictionary. It's an empty dictionary. All right. So again, we're going to start when we're using a cache. You want to check that something is not there. That's the easiest way to do it. So line 8. What are we checking for to not be there?
Oh, is it the a null?
We're looking for our parameters.
Oh.
So if parentheses x, y, z, that's got to be inside of our function. Parentheses, parentheses, parentheses. I didn't add, no list, just parentheses. X, Y, Z, we have a Z with our parameters. If X, Y, Z, not, the word not, where are they not going to be?
Inside our cache?
Right. So if,
I'm sorry, would the exclamation point not work because it's not a calculation?
Because we're doing not in cache. That's why we need it. If X, Y, Z, not in cache, then if X is greater than or equal to 0, sorry, is X is less than or equal to 0, no parentheses here. The only reason that we're looking for X, Y, Z in parentheses like this is because it's a tuple. It's a little grouping. So if all of these things all together. So in our if statements, we don't normally need to say, like, it's not JavaScript. We don't have to say if this curly brackets, more curly brackets. The only reason for using these parentheses is to show it's a grouping. Okay? All right. If X is less than or equal to 0, colon. Make sure you put a colon at the end of your conditionals, right here. Line 9. Line 9. There we go. Cache.
that bad with the space in between?
You should keep it together. Keep them together. There you go. X less than or equal to 0. Cache. Now, how do we instantiate a new key in our dictionary? With a, what do we got to do? Need a key. So I need cache with my bracket notation. And then what goes inside our bracket notation? Just like last time. Parentheses. Parentheses. When we put our parameters in there, right? So again, they could be numbers of 1, 1, and 1 perhaps, equals y plus z. All right.
I don't need the parentheses.
No. No parentheses there. Else. Else it does not go inside the if. Else goes one back. There you go. Else cache now Tita.
Oh, we're gonna add it in like last time.
Yep, we're gonna do else cache, and we're gonna give me a new key of the same parameters. And now, this is what's gonna make it expensive. We're gonna do some recursion. Yay! Cache
Yay!
equals. Yay, recursion! So, expensive sequence.
You get recursion, and you get recursion, and you get recursion.
Everyone gets recursion. All right, so now we're calling expensive sequence. And inside, we're gonna have x minus 1, comma, y plus 1, z, plus expensive sequence. Inside, x minus 2, y plus 2, z times 2. Outside, plus expensive sequence. X minus 3, y plus 3, z times 3. And that's our new cache. Now we're going to return all the way over. Return our cache. XYZ. How do we access it? There you go. Ta-ta! All right. So, again, what's the first thing we do? We checked that our key is not already in our cache because we don't want to do the same math again. Doing the same math again is the worst, right? So we've checked It's not there. Then we check if x is less than or equal to 0, because there's some math that we need to do. And it's a lot easier to just add y and z. Should have done the readme first, but I'm trying to get through this in one go tonight because I'm sleepy. Else, we're going to do all the math. The reason we're doing recursion even though it's expensive to do recursion in terms of time complexity, using the cache makes it not as expensive, so it kind of like balances out with some kind of space-time complexity math. In a wibbly-wobbly way. We can do this. It will give us our answer, and it will continue on. All right. Does that make sense?
Yeah, would we say that we're adding to the cache?
Yes, we are adding to the cache. We're creating a new key value pair, and we're adding to the cache. All right. We're good on this one making sense?
Yeah, I mean, I guess Doc's not answering because she knows all this, like.
Yes. Doc is there for when I mess up.
Oh, okay. And we lost that other student, but that's all good. So yeah, it's very similar to the last one where it's like we instantiate a cache, which is similar to an empty dictionary. The difference being, I mean, I know the dictionary we use the hard brackets, the square brackets, but
No, the dictionary we also use curly brackets. The list is the square bracket.
Oh, I'm thinking of a list. You're right. So, but what's the main difference again? I know what a cache is. It's like it's for easy recall. Or a couple.
It's for easy recall. Something about non-matching things. Basically we're pretending that we're using a hash table.
Okay. But I mean, the cache is different from a dictionary. Is harder to access than a cache.
No, they're accessed the same way, but we're just pretending we're using a hash table because on a website this would be weird. I'm building a cache on the back end, and it's accessed kind of similarly, but there's extra steps. So
what would be weird? To be using a dictionary or a cache or a hash table?
If you're using a proper hash table, it's a class structure. So we are pretending that we're using a cache. We're pretending we're using a hash table because it's easier to write it this way.
Okay.
And I don't want to go through all of those class functions.
Oh, I see.
So.
Okay, thank you.
So that's basically it. Cool. We have 7 minutes. Our next one that we're going to do is the word count.
Where is that?
It's in applications under W for word count.
W.
W. A little lower.
It's still.
W's at the end of the alphabet.
Application. Oh, down more, you mean?
Up. It's still in your application. It's just your word count. Right. Applications. Inside your applications, word count. There you go.
Okay, sorry.
All right. So in this, what we're essentially going to do is we are going to count. We're not actually counting how many words. We're going to I'm looking at word count. Yep. We're going to we're going to count how many times each individual word appears in these sentences. So the word hello appears 1 time in this sentence. The word hello appears 2 times in this sentence. And the word hello appears 0 times. So we're going to count the number of times that each individual word appears in each sentence. One sentence at a time. All right, so we'll get started on this. Now this time, inside the function, I would like a cache. Give you a little cache. You could call it whatever you want to call it. We're going to call it a cache. Cache equals what? You need to set it. Cache equals an empty bracket. All right. The next thing we're going to do is we're going to create an array from our sentence. While you can iterate through a sentence, you can iterate through a string. When you iterate through a string, you go character by character, and we need to go word by word. All right, so the next thing, we're going to be right here, line 9, inside our definition, inside our function. I called mine s_list, but you can call it whatever you want.
Yes.
Equals.
Oops. So because
s.split. Yep, sentence list. S is our parameter that we've been passed up here. See? Parameter. We're using our parameter. S.split, and then invoke it. Invoke it. Invoke x.split. Invoke. No, line 9. Invoke. There you go. What this does is it automatically splits our sentence at the spaces.
Okay.
And it's going to give us an array of words that have been split at the spaces. This is really important for basically every code signal thing because they always make you do something like this. All right, now we need a for loop. Nice for loop. So for every word, so probably just call it word to make it nice and simple, but for word in our sentence list, colon. So now for each word in the list, I'm going to send this to you because we're going to do something cool. We're going to strip. This is going to be in the, whoops, just send this properly. Word equals word.strip. And please take this right here that I sent in the Zoom chat.
So where is that? More?
If you're sharing your screen and you go to the top, you should drop it down. You should see some like little 3 orange dots blinking bright orange.
Oh.
So you're just going to take that and paste that over because this is the strip, and it's going to be hard for you to type out.
Okay.
All right, so word equals word.strip right here from the at to the left, delete.
Is it here?
Yep, there you go. Delete that.
Oh, okay.
And then replace and then delete this part there. There you go. So what strip does is it cleans the data, right? You're in data science, so you know you've got to clear out a whole bunch of stuff. So strip, we're just getting rid of all of these random symbols. So word equals word.strip. If that needs to be
Yeah.
equal with the word. Yep. If word strictly equals, so now we use a double equals as a comparator. Good. Empty string.
Oh,
Empty string.
Oh.
String. Empty string. So that's just 2 quotes. There you go. If word equals empty string, colon, continue. All right. Word. All right, so now over here, line 17.
Okay.
Word equals word dot lower. Invoked. Good. What word dot lower does is it allows us to, it basically makes everything lowercase so we can compare everything exactly. And if, so what are we looking for now, Tita? So if the word is not where? So if word not in
Cache.
Yes, good. If word not in cache.
Whoops.
So then we're going to create an entry. So how do we create it? We create it by going, we need to create our key value pair. How do we do it? How do we do it? No.
No?
No. That's only there if there's 2 things. There's only 1 thing this time. So
No.
no, put it back. You were really close until you added those parentheses. Yes. Now inside what goes inside them? What's our key?
Is there a key? Oh.
What's our key? Word. Yes, the key is our word.
Okay.
Good. And our word is we're going to start it with a count of 1. So word equals 1. No, go, back up. Yes. We only have our key. I need a value. Our value is, Tita,
Our value
is 1. And our
oh,
value,
because it showed up 1 time.
yeah, that's right. So outside of our little key, there you go, equals 1.
Okay.
Because it has showed up 1 time. All right. So if it has shown up before, so we have else.
Else if.
Oh, we don't need an if. We have an else already.
Oh.
So
Oh.
if the word is in the dictionary, so the word's not in the dictionary, we created the word. No. What do we got to do? We got to count the words. How do we count the words?
Oh.
We're going to go cache.
Actually, it goes cache plus 1.
Cache word.
Cache word.
Plus equals 1. So we're increasing the counter value on that side that. So as I said before, we would have our word. So our word is, let's say, hi. And we start with it at 1. Next time we see it, we'll have hi. And then we're going to increase it by 1. So hi has shown up 2 times.
Okay. Okay.
So you're going to see this a lot in code signal and it's one of those questions that might show up on the GCA. So on line 23, what do we return? Perfect, returning our cache. Exactly. So we've gone through. So first we start off with our little cache. Then we created a list from our sentence. For every word in our list, we removed any extra punctuation by using this really cool method that Python has. If our word didn't actually exist, we continue. We make sure that all of our words are lowercase. If the word is not already in our cache, we're going to add it by creating our key, which is cache word, and setting it equal to 1. Otherwise, we have our key and then we increase the value by 1. And this particular pattern happens pretty frequently. It's something you're going to see a lot when you're doing fun little code challenges. All right, does that make sense?
Yeah, I mean, it seems similar to the last two also.
Ah, a pattern emerges.
Yeah, but the other two, I don't remember us having a counter.
Nope, this is a new thing. We're counting words. This will be a pattern. We were counting words. There's going to be other times when you'll be asked to count letters or count the number of times that something appears. Or, you know, in your labs project, you may have to count the number of X amount of times that this thing shows up in your data sets. So this is something that's pretty important and something that you should learn how, make sure you understand and learn how to implement this particular pattern. Because it's going to show up again. All right.
You're talking about using a cache in particular or just counting, keeping track of stuff?
Both.
Okay, thanks.
That is something that I was so excited when I learned that we could do that. Like, that makes so many algorithms easier. All right, so our final one for the evening is no dupes.
Okay. Okay, no dupes.
No dupes.
Oh, no.
There you go. No dupes. No dupes. All right. So
It's like dupes to me, but it's cool.
It's because it's short for no duplicates.
I figured.
No dupes. So in this function, we are going to go through our string. And this time, instead of counting how many times the word shows up, we're going to remove the words. Ooh. Which is not using a cache, and I don't really know why. I don't know why this one's in here, because it's easy to not use a cache. So the first thing we have to do, so we're given a sentence. Tita, what did we learn in our last function? How can we split a string into a list?
Oh, we did you used the split function. So
Yes.
we'll do f.split.
Mm-hmm. So to give it a variable name.
Well, we can't. Yeah, we just use s, right?
Well, we're going to have to name the thing that we're splitting. So,
okay.
as we did last time with sent list. Yeah.
Okay. Split sentence
equals
s.split.
Great. So that's the first thing we have. Now the next thing, we need an output. In this case, our output is going to be a string. So we're going to have an output sentence, whatever you want your output, your answer to be called. I called mine output, equals, give me an empty string, please.
Empty string. Oh.
Is that empty?
Oh.
There you go. So remember, we got an empty string. empty string. All right. Because they want our output to be but because they want our output to be a string. So now we're going to loop through our list and get each word.
Okay, so then for word in split sentence.
Very good.
Forget. No.
If, we're going to use another cool one. If output dot find invoke. Now what's going to go in there? What are we going to look for?
Here we're looking for, I guess we're looking for dupes, but.
So what's our what is our current variable?
That one?
Word.
Oh, okay.
So if we find the word in our output sentence.
Okay.
So if output dot find word.
Okay.
Deeply equals -1. So if it's false. If it doesn't, if it is deeply equals -1 colon after the -1.
So would this be returning a -1 or just setting it equal to? We're comparing it.
It's comparing it.
Okay, so if we find compare it to -1, but are we able to compare a number with a word?
Because what it's spitting out is
Boolean.
Yeah. Is it because what output dot find is returning is giving us a -1 essentially. Then we're going to set the output. So output sentence. So we're going to make it equal to the output plus the word plus a space. So what that has done right there, so we have our output let's say I, that's our current output sentence. So when we say is equal to I, then it has a space, and then it has another word, cat. And then it's going to add another space right there. Now the problem with this is that it's going to leave us with, what's it going to leave with a space, not an empty string, a space.
Oh.
So there's a slight problem here, which is that this is going to leave us with a trailing space, right? Plus empty, I need a space right here. A space is a string with a space inside of it. A string with a space inside it. No parentheses needed. All right. I need a space inside those two little quotes. There you go.
That means it's a string and a space?
Yes. So an empty string has nothing inside it. A string with a space inside it is a string, and there's a space here. Okay. So we need to have a space. So what this is going to return to us at the moment will be something like, if we look at line 20, would be cats space dogs space fish, and then we have a trailing space. That's problematic, isn't it?
Yeah, like when we use the linters on it, we try to get rid of that.
Right. So easy way to do this, return so what's the easiest way? We learned another function, we learned another method tonight.
Oh, was it the strip?
Mm-hmm.
Okay, so return output. That's
Got it.
strip. Uh,
And then inside the strip, we're going to put quotes with a space inside. With a space inside the quotes. Space in the quotes. There you go. The end. So that's remove the trailing space.
okay.
All right. So how we did this was we started with our parameter, which was a sentence.
Mhm.
We split our sentence into a list.
Okay.
We instantiated our output as an empty string. An empty string, does an empty string have spaces, Tita?
Empty string. No, but if it has a space inside it, it does.
No, if it's a space, it's not empty.
If it's a space, it's not empty.
If it's a space, it is not empty. A space is a string with a space.
Okay.
This takes up. I'm fair. Does a space have an ASCII value, Doc?
Yes, it does.
There you go. Space has ASCII values.
Okay. So,
An empty string has nothing in it at all.
oh, okay. So this is incorrect notation. I said string with a space has two spaces. It should have
One space.
all right. Thank you. Only one is just no, nothing. It's just the empty space.
Yep.
Nothing
Nothing is an empty string.
is an empty string. Okay. Yeah. Great. Too
Does that
bad.
make sense?
Yeah, this is stuff I wish I had down already. But yeah, boot camps not in my future after this, hopefully.
So we have our sentence. We split it into a list. We initialized, instantiated an empty string. That's going to be what holds everything that we have.
Okay.
And then you did a great job with our for loop. For every word in our array, we're checking. So in this case, our output sentence is being treated kind of like a cache. It's not being treated like a cache. Kind of like, don't eat me. We're looking to see if it's there. If it's not there, victory, we add it to our output.
Okay. So comparing this, if we find the word in our output sentence, compare it to -1 because that's, per the find function basically.
Yep.
Okay, which returns -1 or 0 or something.
Pretty much.
Okay. Okay, so and then the output sentence, and then otherwise, wait. So this means if it is in our fake cache or non-cache,
Then we're gonna add it by
it's basically it's a list. So if our word is in our list,
it's not a list, it's a string.
Huh?
Our output sentence is a string.
Okay. Okay, output sentence is a string.
So our output sentence is a string. So we're checking if it's in our string, then we continue on our merry way. If it's not in the string, we're going to take the string, we're going to set our current output to what our current output is, and then we're going to add another word to it.
Okay. So.
And then we're going to give it a space.
So if the word is not in our list.
In our string.
In our string. We add it.
Yep.
Space inside is one space. Oh.
We add it, and then we add a space at the end so that we're not going to have like dogs, cats, fish. We're going to have dog space, cat space, fish space, and then we're going to strip the final space off of the end.
Okay. All right, sounds good. So I'm just trying to finalize this. So if it has one space, that means it's not, it's a string, but it's not empty.
Yes, that's right.
Okay.
If it has a single space, it has an ASCII value, so it's not empty.
Is a non-empty string. All right.
All right, that is this evening.
Thank you. That was very helpful. I got all your attention. Makes up for missing all the other ones.
Yeah, you got one-on-one time with me and Doc.
It's the only way I survive.
So tomorrow is going to be some really, really cool and crazy concepts. We've got histograms, we have Caesar's lists, we got Caesar's ciphers. We've got cool stuff. We got Markov chains. Super cool way to use hash tables in a data kind of way, in a cybersecurity kind of way, and all sorts of different ways that we can actually implement this data structure.
Oh, that's what these other files are.